In this video, we'll discuss the machine learning capabilities of the Forcepoint DLP product line. As a quick primer for machine learning, it's an artificial intelligence capability to learn data and then protect potential theft or leakage of similar type data. So we'll focus today around the zero-day use case, and rather than give a large introduction to what we're going to do, I will sort of just jump into the use case examples. The particular one I'm going to discuss today is sort of around the entertainment and media space and around manuscripts. So what we'll do today is do a machine learning task against some famous Hollywood movies as well as TV series, removing some of the newer episodes or movies in the franchise and being able to use the machine learning artificial intelligence to act upon when that new content or that zero-day content is leaked. So what I'll do is show you the content, I'll show you the policies and the machine learning classifiers, and you'll get a good idea of how this solution works. But to start, what we'll do is we'll look into our content classifiers machine learning area. And I've actually created two machine learning cases here. I have a Seinfeld manuscript machine learning job, and then I have a Star Wars manuscript machine learning job, and these are all custom made, and we'll go through them. But what I'll do is I'll show you the content first, then we'll walk through the process of positive and negative, then I'll show you the policy, and we'll show how accurate it actually is. So what I've done here is created a folder, and I went ahead to a very popular website which has the manuscripts, and I downloaded the manuscripts for kind of the first 6 Star Wars movies, the original ones, the 3 that came out in the 70s and 80s, and then the 3 that came out in the early to mid 2000s. So you'll see those there, and what I've done is I split each manuscript into 6 subversions, to increase my file count, as well as to kind of break the data up so it's not as static as just one file. But we have Phantom Menace, which is episode 1, Attack of the Clones, Revenge of the Sith, which is episode 3, then New Hope, which is really the first movie, episode 4, Empire Strikes Back, and Return of the Jedi. And we'll use this as our sample data. What's missing in this sample of data is the Force Awakens movie, which came out much later in 2015. But it's obviously part of the Star Wars franchise, and we want to prevent, because maybe we're actively contributing to that script now. It hasn't come out. Obviously, everybody wants to know what's going on in the new Star Wars movie, so that will be our zero-day, file or content that we want to protect against. That hasn't been fed into the system, but what we'll do is we'll learn enough about the Star Wars movies, predate it, that we can prevent leakage of unknown future content, which is really the value that machine learning brings to the table. So what I'll do is I'll show that I have what's called a negative folder, and this will all make sense in the policy, where I actually took mostly sci-fi movies, a couple comedies and other things, but most of this is sci-fi related, so still in the future, technology, spaceships, etc. And I'm going to feed that as negative content because I'm only responsible for Star Wars. I'm going to increase my precision by showing it similar examples that aren't uniquely my content. So all the Aliens films, the Star Trek films, Terminator series, some other ones in here, and you can kind of get the picture. So it'll really increase our precision around the Star Wars universe, so to speak. I also will go in my Seinfeld, and I have all the episodes of Seinfeld in here except for the 2 finale episodes. So if you look, I don't have the finale episodes. I'll leak those out after, so they will not be part of the training. And the goal here is that it's kind of the end of the Seinfeld production era, and it's time to write the finales. Everybody wants to know what's in there. It's a high leak risk. So as that content's being developed, even though it's not completed and hasn't been fed into the system will be able to block based on its intelligence from the other 170, 180 episodes. And just to show you the content real quick, and I downloaded this from a popular website that has every Seinfeld script on it. But you can see this is just a particular episode called The Beard. It's going to analyze all of this, compare it with the other ones, and we'll run it against the negative examples, the same ones, the movies, etc. And what I'll do is demonstrate that we can stop the finale. And in both the Star Wars example as well as the Seinfeld example, I will leak content that is very similar to Seinfeld. I'll use Frasier as an example in this particular case, and we'll notice that that doesn't leak, because that just shows the sensitivity and precision. Similarly, as I go back to my movie example, I should have noted that The Fifth Element, the movie, is not listed in the negative example, and it's obviously not in the Star Wars positive universe. So that's an example of a file that we will demonstrate that we can send and move because it's not part of the Star Wars file or the negative file. So it just shows, again, the accuracy of the solution. So what I'll do is I'll close this and we'll walk through the creation of the machine learning classifiers. So it's very easy to add a new one. But to save time, I just actually created these. You can see they were created like less than an hour ago. I'll go through the process. Obviously, you give it a name. This will be referenced later in the policy and the rule. We're going to use a network discovery crawler to crawl a data share on the network. We're going to give it credentials. We're going to point to where it is. And then we're going to select the folders. So in this particular case, you can see if I browse based on the credentials on the previous screen, we'll be able to see that we're in the manuscripts positive folder, and we're going to look for all the files that I showed you in that Star Wars split folder, which again, if we look at New Hope Part 1, you can see that a long time ago, et cetera, et cetera. Again, this was downloaded from a popular public website, but this is the entire 1/6 of the script of A New Hope. So we're going to pick up all of that. And then I'm going to go ahead and do the negative examples, which again includes the Terminators, the Aliens, Star Treks, etc. Obviously, these are the folders. There's some other in here. We're just selecting the folder at this point. And that's really it. There is some content type things, but I'm just going to use basic machine learning AI with no extra help on it. And then you can schedule when you want this this job to run, which it's already ran. So pretty simple there. You can see based on the content of positive and negative, it gives you an accuracy score. Obviously, the higher the better, but we're in the 90+ percentile, so this is really good. That means the source content that we're providing has a lot of commonality and similarity to it. If you were to use a wider breadth of products like sci-fi movies in general, that accuracy would go down. But Star Wars is kind of unique to Star Wars. Seinfeld, same thing. I'll be real quick here. Just going to the scan folders. We'll see that manuscripts positive Seinfeld and manuscripts negative is being used. And that's really it. Afterwards, you will have these content classifiers available to you to put into a policy. So if I go into my policies, you can see that I have a variety of machine learning policies available. I'll just show you one because they're constructed exactly the same, but I'll show you the Seinfeld scripts. It just shows again how easy it is to make a policy and how versatile it is. So it's inside of the machine learning policy that I made, and I'm going to make the Seinfeld ML rule. As far as the condition, I just go in and I add my content classifier, and that way, if I run that if I run the machine learning job again, as if I feed it more and more episodes that I've created, I don't need to do anything with the policy. The system will automatically update and become more accurate as we feed it more more information. But again, it's designed to know about the data before it's even created, and that's what we're going to demonstrate. Simple policy. If anything leaks that's Seinfeld related, I'm going to mark it high. I'm going to block. I'm going to take all the sources and all the destinations. And this is covered in a more comprehensive DLP demo, but I basically have all my content sources. I will demonstrate leaking to a USB drive. So you can see that that's checked here, and that's really it. So what we'll do is go back to our incident dashboard. You can see that I don't have any incidents in the last 7 days. So we're going to show you some live fire examples here. So I'm going to go over to my client, and I'll increase the size here. And I have this trigger files folder, and we're going to use some of these. For instance, I mentioned that I'm going to leak The Fifth Element. The Fifth Element's not part of the Star Wars franchise, although it has commonalities in spaceships and everything like that. But this is the full movie of The Fifth Element. Again, downloaded from a public site, and I'm going to go ahead and copy that to my USB drive. And because this is not protected content, it's not part of the Star Wars universe, I would expect this to get leaked. And it was not an explicit negative example either. Star Trek was and all those other things, but it's not Star Wars, so that actually leaked. What I'll do now is take the entire manuscript for Force Awakens, in its entirety. And again, this was not fed into the system. The system's unaware that this movie existed or any of this content, but obviously a word like Stormtrooper and other things have some commonality in there. So if I try to leak that to the USB drive, you'll see that our endpoint blocked this. Now again, the network DLP protectors and everything like that would also block it. But as I refresh here, you'll see that I cannot block it. So based on artificial intelligence, the system determined that this fits a match into the Star Wars realm, and it's not just looking obviously at the title. Similarly, I'll go and close that. I have the Frasier episodes. These are the 2 finale episodes for Frasier, which were downloaded from a Frasier fan site. And I can take both of these and I can copy them. And similar to the Fifth Element, it's not part of the Seinfeld, or in this case, Star Wars universe. So they're able to be copied because maybe that's something that, hey, I want you to read the Frasier finales. I think they did some cool things here. We should incorporate some of those ideas into Seinfeld. I'm not a script writer, so whether that happens or not, I don't know. But it's just an example that we don't want to break productivity of sharing other content. We just want to protect our content. Meanwhile, I have the Seinfeld finales here, which obviously are a high target thing when they're being developed, and you see they're protected in the studio for some time before it goes on air. But if I try to copy these files, you'll see that they get blocked. So exactly the same as the Star Wars example. And as I head over to my incident dashboard now and refresh it, you'll see that all 3 of those, the Star Wars movie, Force Awakens, was blocked, and then the 2 finale episodes, but Frasier and Fifth Element was not. So we'll start with Star Wars and we'll review what we have here. We basically are using our endpoint removable media capabilities to block explorer.exe copying to a USB device serialed here. We can see that the Force Awakens.txt was the file. We've captured that file so it can be reviewed by an analyst, and optionally an analyst that has access to forensics content, because maybe this is so sensitive even the frontline analysts can't see it. They can download it and review it, and of course if we look at the past history, we can know that it was George Washington. We know exactly what he was doing with it. Over here we can see that this violated the Star Wars ML rule, or the manuscripts rule, and we can click on the details and see that we had a high level of confidence, 92%. This was a Star Wars related thing, and you can see some of the high value words. Luke, for instance, right? Jedi is a very unique terminology to Star Wars universe. So is droid, although it's a little bit more universal. But Skywalker, you can see, and this is just 50 is kind of the max that we'll show, but these are the value words. Now, some of these words were also in the Fifth Element, but it couldn't be, there weren't enough of them and enough high value ones to get the level of confidence high enough to trigger the policy. It's worth noting that that's adjustable. Similarly, if we go over to Seinfeld, again, we can see everything about George Washington, the file he put. If you'd sent it to somebody via email, like in a Gmail example, we would see that he emailed it to himself or said, oh, here's that script, I'm about to resign. You could put together the story of what this user was doing. Again, forensics files copied, and we can see that, in this one, 100% confidence, but you can see that words like Kramer, Constanza, etc. Were in here. Elaine, amongst other words that are kind of more common in the sitcom realm. But I'm sure Frasier had many of those words as well. And again, here's the finale 2, which was also blocked. So real simple. It takes only moments to set these things up based on data. You don't have to create advanced, exotic, multi-rule things where you're creating classifiers for words like Kramer and Seinfeld and everything like that. But one other thing I'll point out before concluding is you can adjust the sensitivity. All the settings that I used were the complete defaults. So you can increase your sensitivity by widening the net, so to speak, which does increase the possibility of false positives as well. And then you can ignore inconsistencies. So that's really it. It shows you how powerful the machine learning artificial intelligence solution is on the Forcepoint product line.